Welcome, my name is Eleonora, and today we'll talk about thermochromic liquid crystals. First off, what are liquid crystals? Well, liquid crystals are a particular state of matter that is in between a solid and a liquid. Liquid crystals are in fact able to flow like a liquid, but their molecules show the properties of a crystal. And how can they do that? Well, this depends on the shape of their molecules. These are normally long and tend to align in a particular direction. Take, for example, a bunch of spaghetti. I'm Italian, of course I had to have a pasta analogy. If each spaghetto is a molecule, you can see that they tend to align themselves all in a particular order and direction. However, they can also flow like a liquid. Yeah, who's gonna clean this now? And what are the properties of these liquid crystals? Well, for example, they can interact with light. Here we have a very thin sheet of a thermochromic, chiral, nematic liquid crystal. Phew, that was a mouthful. Thermochromic simply means that this material will change color depending on the temperature. Here, to show this, we are using hot and cold water. Pouring cold water on the sheet will force a change in the structure of these molecules, and pouring hot water will then revert this change and push it towards the other end. So what is happening? Well, this is the structure of this particular liquid crystal. Each layer is composed by molecules aligned in a particular direction. Each subsequent layer is rotated of a certain angle from the first one, and so on until another layer will have the same orientation as the first one. This distance is called the chiral pitch, and it is generally of the order of hundreds of nanometers, which is basically the wavelength of light. When the sheet is cooled down, the molecules on each layer rotate of a small angle, increasing therefore the pitch, meaning that the light that will interact with the film will reflect with the same wavelength of this pitch. For longer wavelengths, the colors will shift towards red. When the sheet is heated up, each plane of the molecules will rotate more. Therefore, the pitch will be effectively smaller, so shorter wavelengths, and we will then see colors shifting towards blue-purple. The film looks black at the far end of the spectrum, where the pitch is so small or so big, the light doesn't interact with it anymore. So this is pretty cool, but what are the applications? Well, in this case, these materials can be used to measure temperature in a particular range. In other cases, liquid crystals are, for example, used to turn pixels on and off in LCD displays in response to an electric field rather than temperature. Well, I hope you enjoyed this short intro on this really fun material. See you in the next video, and thank you for watching!